Hello everyone. Today we are going to do our program in Java. So this program is for the Quicksort algorithm. So in this algorithm, what we do, we divide, sort an array or given elements by the approach of divide and conquer. So first we select a pivot quickly, then we arrange the array in a manner that all the less than items will be in the left side of the pivot and all the greater than items will be on the right side of the item. And then we partition the array in two parts, from the pivot from the left side of the pivot and from the right side of the pivot. So then we again do perform the same operation recursively. So let's just implement quickly it in the code. So let me just give it a Java project. I can give it a name, pick so algorithm, and then I don't need Java file. Oh, yes. And now I have to create a class. So this class will be Quicksort Algorithm. Quick So algorithm. And I want it to be public static void main. So my Java runtime environment can call it. And now we have auto generated code. So let's first discuss our algorithm. What will be the approach? So let's say we have an array of just take a small array, let's say first. So let's say it's 3, 2, 1, and again 2. Just take number 4. So what we are going to do here is first we will take two pointer. One will be the lowest side and one will be the highest side. So three first left pointer will be on the 3, right pointer will be on the 4. Now we are going to select a pivot value randomly. Either we can randomly select, or we can select the middle value, or we can select the rightmost. So in our case, I'm going to select the rightmost value. So left, this will be the left pointer, this will be the right pointer, and also my pivot is going to be pivot or pivot also going to be on the fourth number. So what we will do is we will look through each of the item. Then what we are going to do is compare. If first we will do with the left side pointer. So let's say if 3 is less than or equal to 4. So 3 is less than. So what we are going to do, plus plus left pointer, so it will come to 2. So it will be 2 less than, and 1 is also less than 4, so nothing is going to happen, and the left pointer will reaches to 4. So in this case, what we are doing is we are sending from our left pointer, we are increasing from the left pointer, so we can get an item which can be the, if an item is bigger than 4, then we will hold our left pointer here, and if our item is greater than, then we will start our right pointer, so we will start counting from here. Then we will find out if that item is less than. So if that is, then we will swap those both of the items. So in this case, nothing is going to happen because all these items are stored from 4. So what we will do is the high index 4 will be swapped with the left index, which itself is 4. So let's first implement this in the practice. I don't know, I can make you understand or not, but let's just implement it. So what we are going to do first is we are going to generate an array, so we can sort it. I will take a random argument, random, new, random. In Java, we can generate random things and import random fields. Then I will have an array which can hold all the random item up to the given number. So it will be int array. It will be, I will give it array equals to int, and I will give it the size of 100 initially. Now we have to generate an array like with the random numbers. So I'm going to loop through the each of the item of the random this array.length. So int I equals to 0, I less than equal to array.length minus 1, or we can just do I less than array.length, and it will be I plus plus. So for each array index, I will put a random value. So it will be the extent, and we can give like a number. So I will generate the number between 1 and 100. So our array has now values. Let me just print it quickly. Before sorting, our array look like this. I will have to print this array. I will have to look through each of that. And after the sorting, we will also need this. So let's just create a function out of it. So it will be private static void, and it will be print array. It will take an array as input, and it's going to loop through each of the item. I equals to 0, array dot length is 1, I plus plus. So I'm just printing the array system. So I will be printing it in one line, so I don't need print ln. So I will give it some space after the number. So when next item comes, they both will have space between. So I will print array, then its ith position. After that, let me give a new line. So print ln. Also, I want new line to be one more space. So it's Eclipse is complaining the method is not in use, never used. Let's use our method. Print my array. Okay, now let me run it. So as you can see, we have too many items randomly generated. Let me reduce the size to 20 so we can have a better view. So run it again. Now it's good. Control Shift plus. Why it's not zoom in? Okay. Shift plus. Now this is before the sorting. Now we need to sort our array. So for that we need a function which applies our algorithm. So I will create a private static void quicksort. So what it's going to take, it will take an array as input, array left, not left, slow index, and I will give it a also high index, which will be the last item. High index, and the both are going to be obviously integer type. Now, what we have to do, the first step we see here, we have to select a pivot. So let's just select a pivot. So this is not JavaScript, obviously. So int pivot equals to the value of the last. So I am selecting the last item as the pivot. Now left index for the pointer will be equals to low index, and the right index equals to high index for the right pointer. Now our main logic comes here. So we have to loop through until both the left and right pointer didn't overlap each other. So we can find out that all the left items are smaller and all the right items are bigger. And if there is any mismatch, then we swap them and make it like all the smaller item on the left side and the greater items on the right side of the pivot. So just remember the logic. Left index should always be lesser than left index should be less than right index. So here what we have to do, we have to start from the left side. First, we will sort the left side of there. So let me just increase the pointer from the left side. If so, until I don't find a greater than value than the pivot, I'm not going to start the swapping with the right side. So first, let me find the greater than value on the left side. So what I'm going to do here is I'm going to calculate if array left index, if it's less than or equal to the pivot, then we will just increment the pointer and don't do any swapping. And then obviously the left index should be less than right index, so it just don't come again and again and make it an infinite loop. And what I'm going to do, I'm going to do left index plus plus if it's not the greater item of the pivot. Now we have to count the position of right pointer. If we found an item which is less than the pivot, so after that, what we can do, we can swap left index and right index with each other. So the smaller element come to the left index position and the greater element comes to the right index position. So this will be while left will be the same logic, just right index if greater than equals to pivot at left index is less than right index. So right index will be minus. So because we have to move on the left side. Now let's say we have both the items. Let's say the bigger one on the left side and the smaller one on the right side. So what we have to do, we have to do swap both the items. So I can just take a int temp equals to array left index, then array left index equals to array right index. Now array right index will be equals to the temp. And now this swapping is done. So we will exit from the while loop. And then we will swap the higher index, that pivot with the left pointer. So all the greater than value should go to the right side and the smaller one on the left side, because the left side pivot is the greater than right current item at the left index is greater than the right index that pivot item. So what we are going to do, we are going to do the same again. Int temp equals to array. It's becoming redundant. Let's create a function void private static void swap. It will take an int array and it will take left index, right index. And what it's going to do, it's going to just do this thing. Obviously, it's not JavaScript, it's Java. Okay. Now I have to use the swap. This is done. Now I have to use the swap also here. So we will send array. Then we will send also the left index. And also we don't want to swap with the right index. We already did that. So I have to swap with the high index. So the left item and the pivot are going to be swapped with each other. So let's just run our code quickly. So how it's going to be done? We didn't pull the console.
I know you told your friend you're not okay, and tell me what's wrong and why you never said you felt that way. And guess you're trying to stay strong and fake a smile until I look away. But I've known you too long, it hurts to watch your blue eyes fade to gray as you fade away, as you fade away.
Yeah, I'm about to fade away. Cause every time I wake up I feel like it's Monday. Something's going wrong with all the chemicals up in my brain. All of a sudden I don't look at anything the same way. Gotta build up of my thoughts sitting in an ashtray. I'm sorry.
Pivot. So 42 is here, and all the right side items are greater than 42. See, 97, 82, 62, and all the items on the left side 42 are smaller than. So we did this one time for the whole array. Now what we have to do, we have our pivot here. So we have to perform the same operation on the right side. We have to perform the same operation on the left side. Also when it's sorted, then we have to perform on the left side and right side also until the array become just array will have only one item. Same it's going to happen on this side, then the whole array, then we are going to have new array on the right side, and we will recursively solve this until it becomes only one item in the array. After that, it will be merged together. It's not merge, it's just sorting in place. It's using only one array, the given array itself. So let's implement our logic here. So after the swap, what I'm going to do, we have to call the quicksort in recursive order for the left side and for the right side. So I'm going to call it quick quicksort array. Then the left side index will be the low index. Yes, it's always going to be on the lowest index. So it's 0, and then the next time the index is whatever the we having the array size. Now high index will be for the left side of the array. It will be the left index -1 because the current element at left side is the item which we just swapped. So it will recursively solve our left side array. Let me show you how it will work. Index -1 out of bound for length 20, yes, because where its lower index can become -1 or 0 or something, because it's going to have one item in the array. So what we have to do, we have to check it should not be -1 in any case. So if low index is greater than or equals to high index, then I am going to return, just return, and end the recursive calls here. Let me run it again and see to work. So our pivot is 85. So search where is 85 here. See 7, 13, 15, 17, and all of these items are sorted until here because it's calling on the only left side. So you get my point. It will call on this side, and what is going to become? It's going to take a pivot and pivot, and then this will become right side array. So it will not be sorted. Only this side will be sorted again. Then the left side array again sorted again. So it's just sorting the left side array, and it's sorted until here only. And we still have some items like 35, 33 here. So what we have to do now, we have to recursively sort the right side array also. So just copy it. So for the right side, it will become left index +1. Because our pointer left index pointer, it at the position where our both the pointer collapse with each other. So left index +1 will start, and our higher index will be become the right side of the portion of the array. So let's say it will be high index. Yep. Now Control S, run. Now our array is sorted 17, 13, 48, 49, 49, 50, and 95. And what else improvement we can do? I guess this is the already optimized version of this algorithm. And let's see how much time it takes to render. Like 1 point, like 200,000. So let me see how much time it takes. Okay, 834, 837, it took 3 seconds, but it's doing because it's printing the array. So let me just comment it out and print it again. See, it just did in just time. So it started at 52 and end at 53. So to sort 200,000. One is cool. So it just sorted 200,000 in just 1 second. So let's increase it and make it 2 million. So let's see how much time it's going to take now. Ow! What just happened? Java.lang stack overflow line number 56 because it's calling again and again and again. Our stack just overflowed. Oh, let me call it for 1 million only. Okay, Control S before sorting and after sorting. So solve 1 million. The algorithm took 25. It took 3 seconds. Great. So that was it for today. And don't forget to subscribe, like anything you can do, guys.